Hey, my name is Paul Wynn, and today I'm going to talk to you about PowerStore, which is the most recent launch from Dell Technologies in their mid-range storage portfolio. So PowerStore is built on three main pillars. We're going to take a quick look at these. The first of these are its data-centric attributes. So it's a platform that's designed for any workload from day-to-day file services and domain services right up to mission-critical applications and OLTP workloads. It's got the ability to scale up by adding more capacity and scale out by adding more than one appliance to a cluster. It uses flash disks in its enclosures, and the base enclosure comes in two options: NVMe or storage class memory, depending on the type of workload that needs to be run. The considerations for the two of these media types would be capacity. So SCM comes in much smaller capacities than an NVMe SSD will. The second pillar is around its intelligence. So there's a lot of automation in this platform, and that's both internal and external. And during today's section, we're actually going to look at some of the external automation and integration points from VMware in particular. There's a proactive capability to this platform. So internally, a lot is happening to assess the workloads that are running and the health and make some recommendations on those. And the third of these are its adaptability. So it's a container-based architecture, meaning we can be more agile in development and release of different features. So there are containers for block services, containers for file services, etc., for the management modules. Lifecycle management for hardware is dramatically simplified with this platform, and it's got a very, very simple upgrade path where customers can install those upgrades themselves once a health check is passed. So the appliance comes in a 2U form factor. It has two nodes in the appliance, and these are active-active. And this appliance is achieving data reduction rates of up to 4 to 1. All of the file services and block services we would require are capable here. So we have 32 gig fiber channel, and we can get up to 25 gig iSCSI with support for lower speeds on both. File services, NFS version 4.1 is supported, SMB3, and VMware vVols are native to this platform also. When we look at the scaling up of the appliance, we can add on an additional 3 enclosures with SAS SSDs in them, totaling a maximum of 96 disks per system, which equates to around 2.8 petabytes of usable capacity. In addition to scaling up, there's the ability to scale out. So I can add up to 4 appliances in a cluster with a total capacity of 11.2 petabytes. And we have 8 active nodes within that cluster. The models vary in range. So entry level starts at 1,000, which is a very powerful piece of kit. There is a 3,000, 5, 7, and 9 at this time. So look at that intelligence I was talking about. Anybody who's working with Kubernetes, there's a container storage interface which will provide persistent volumes out to the Kubernetes platforms. VRealize Operations has got support for PowerStore also now, so you can download the Enterprise Storage Analytics pack from the Dell website, upload it to your VROps instance, and you will get dashboards for everything within the storage portfolio from Dell, plus some of the backup and replication technologies also. Taking the automation piece a little bit further, go to GitHub, do a search for PowerStore, and you'll find a full set of playbooks for both block and file that can be adapted to customers' needs. And we'll look at that as an example a little bit later. All of this is enabled by a very comprehensive REST API. So to complement the REST API, the Swagger is built into the management interface of each appliance. Under the hood, there's a lot of machine learning offering proactive guidance on balancing of workloads. So if we take the example that appliance 1 is getting near capacity, an alert will be generated by the system based on machine learning, and it will determine the best appliance within a 4-appliance cluster to go and move that workload to. This can be done manually, or there's a wizard that will guide you through that whole process. big takeaway there is there's no downtime associated with actually making that happen. So for those people not using VROps for monitoring, there is inclusive monitoring via Cloud IQ, which is at no additional cost. Once the box is phoning home, it's sending support information back. That information is forwarded to Cloud IQ and is collated and converted into a nice presentable system using traffic light colors to make it easy for people to see where they may have issues or areas to focus on their particular systems. Its adaptability is very much around the Anytime Upgrades program, which is new as well along with this platform. So for somebody who invests in, let's say, a 1000 series and takes Anytime Upgrades, the basic entry-level package for that offering, if Dell launches a 1500 series controller as an example, under terms of that contract, after 120 days, that customer is entitled to request those controllers. Now, important thing there is that there's no additional cost for drawing down those controllers. It can be done once during the lifetime of that contract. It's non-disruptive because these are active, and support will be involved in the migration to the new controllers or new nodes. And more importantly, there's no renewal of contract. So you take a 3-year contract, 2.5 years in, you decide, hey, it's time for me to get those new controllers or new nodes. You're well within your rights to go and do that. Then there's a more all-inclusive package that comes with Anytime Upgrades. It includes what I've just spoken about, but in addition to that, let's stick with the 1000 as the example. The customer experiences a lot of growth. They need more processing on their controllers or appliances that are just not there right now. Under the terms of the contract, that customer could move from a 1000 to a 3000, or if they were a 7000, they could move to a 9000. So you're allowed to skip one generation. Now, in doing that, you've now moved arrays, but you also own the original controllers. So you've got the option to go and buy capacity and reuse those controllers as an additional appliance and go and create a cluster. So there's even more protection in that investment. So for anybody considering this platform, it is definitely worth looking at. The models, there are 2 variants. There's a T model, which is representative of our traditional 3-tier architectures. We have storage, we have a fabric, which could be Fibre Channel or iSCSI, and we connect compute to consume storage resources. The second of these is unique to this platform, and that is that the container operating system has been removed from the controllers and is now an ESXi hypervisor has been installed with the container operating system running as a virtual machine on top of that. And what that allows this platform to do is to have virtual machines running directly on the storage array itself. So there are a couple of different use cases here. One of those could be within the data center as part of a vSphere cluster at the core, or as an edge use case where customers got multiple different sites. They want to have resources at those sites with good data services and compute, but they want to do that in a very, very condensed footprint. The Apps-on technology, or PowerStore X, offers the ability to do that. The models align with the T models, so the 1000, 3000, 5000, 7000, and 9000 still apply. The difference being the higher the number, the more virtual machines can actually be run on that appliance itself. There is support for PowerStore within VMware's Cloud Foundation in multi-cloud use cases within a workload domain. And also the storage services extend right out to AWS and some of the other public clouds that are out there. So let's take a look at the appliance itself. Okay, so this is what a PowerStore looks like. Very similar in look and feel to an R740 for anybody who's consuming Dell products already. So quite deep as a storage array. So let's pull off the front bezel and take a look. So there are a total of 25 disks across the front of this box. Slots 0 to 21 provide all of the capacity drives, which can be NVMe or SCM. And the last 4 slots are reserved for NVRAM disks, which are part of the write path for the system itself. All expansion enclosures then will use SAS SSDs. So if we look at the rear of the system, there are a lot of flexible options here. So the very first thing is we have node A, which is on the bottom, and node B is on top. Each one of these nodes has an 1800 watt power supply. So there's shared power right across the midplane. So in the event that I lose the power from node A doesn't go down. Node B has got a sufficient power to be able to run both until we recover the power to node A, which could be the result of a PDU failure, or somebody has accidentally pulled a cable out of the controller while doing some work within the data center. So the first 4 ports here on this onboard module for each one of the nodes is responsible for all of the data services for the appliance itself. Now these are 25 gig capable, so potentially I can have 100 gigs of front-end bandwidth for data services per node within the single 2U appliance. For customers who are running multiple protocols, we can add on some fiber channel modules here, maybe in slot 0, and slot 1 could add some iSCSI. There's flexibility here, depending on what you would like to be able to add in and what services are relevant to your business. These are the SAS expansion slots for adding on enclosures to the appliance, and there are some maintenance ports then and management uplinks for access to the user interface. But let's take a look inside the box. Let's remove one of the nodes and take a look at what we have inside. So these are quite a deep node within the appliance. You can see here we've got 2 sockets for CPU, and if we zoom in a little bit, not as much as that, we've got 7 fans cooling the box. We can tolerate a number of failures of fans in the appliance, but these 2 slots here are where the operating system is running. So the P0 slot, which is battery backed, is running the container operating system for the appliance. It's about 250 gigs in size. And then there's a second slot, which is the P4 card, which is the backup. Should a reimage be required or any kind of recovery, this card can be used in that instance. So that is just a quick look at the hardware itself of the appliance. So what we're going to do now is we're going to go ahead and connect to a system in my lab and take a look at some of the day-to-day operations we can carry out and how PowerStore can integrate with things like VMware. Okay, so we've logged on to a PowerStore appliance, and it is a HTML5 interface. And if we just take a quick look at what we get here, we've got some summary information to show us so overall capacity utilization, the performance of the box at a global level, and some of the services that are running. So we can see here that this particular system is initialized as block optimized. So the NAS capability has been disabled, and by doing so, you unlock the full capability of that box for block services. If you were to use NAS services on this box, then 50% of the physical compute resources would be allocated to the NAS services. So it's something that people should consider upfront. How heavy a NAS user am I? Do I need to configure this box in unified, or does it make sense for me to just go block only or block optimized? So again, I can tell here I've got a single appliance within my cluster. I've got no alerts against the system right now. And under this capacity view, we get an overall look at the system itself, including the savings. So data reduction, deduplicate and compression are turned on by default. They're not configurable, always on. If we want to monitor the savings, then this is where we would look here on this capacity overview. Where we want to look at the performance within the box, we've got a quick look at the main characteristics that we typically look at: IOPS, bandwidth, latency, just to see what's going on. So we can see here we're running around 46,000 IOPS, and our latency is 0.032 milliseconds. And I'm looking at that for the last hour. However, we can go back 24 hours, 1 month, right out to 2 years. So typical day-to-day operation would be, let's have a look at our hosts. I want to go and carve out some storage, present it up to my virtual infrastructure. So here is a physical Windows host that has got a nice SCSI connection on it. I can have a look here at the mapped volumes. We can see what volumes are actually created against it. Now, as we normally would, if we want to go and create a resource from the storage side, we create the volume, we map the volume to the server, we go back to our virtual infrastructure, if it's VMware, we rescan for new disks, and we create a data store on top. This has got many steps to it. However, there's I won't say an obsession, but a lot of people are really interested now in being able to do everything from a single pane of glass. Okay, so how do we get to that with this platform? So first, let's go create a volume just to step through the process. So we're creating a volume here, and we're going to give it a name and call it TVOL1, test volume 1. I can give it a description if I like. If I want more than one, I can have more than one. And I'm going to create that at 55 gigs. I've got the ability to add this to a volume group. So where I've got the things like SQL, Oracle workloads that I want to protect on the same cadence, I can create protection policies and apply them against volume groups. And it just makes things easier for recovery. I can assign a protection policy. So in this case, I've got 3 different policies here. I'm going to leave that off for now because I want to go and create a policy. And then I've got a performance policy. So I'm not asked to choose a RAID type. The performance is there. I just determine what kind of priority weighting I would like. So if I choose low as an example, for all of my volumes, and most of them, and I've got some highs, when the box is moderately busy, this doesn't really come into effect. But when the box gets congested and gets really busy, it's at that point that this policy weighting kicks in. Anything with a high will get priority access to the processing capabilities of the appliance. So go ahead, hit next. I'm going to choose the host that I want to connect this to, which is going to be my Windows host. A LUN ID will be automatically generated for me unless I'm using a custom schema. Then I can just choose the second option here, this radio button, and select the LUN ID that I would like. In my case, this is just a test. I'm happy enough for this to generate automatically. Okay, so I've gone and created that volume. And now if I want to go back and take a look at it, I've got my TVOL01. Look at the protection. I've got no snapshots, no replication against that right now. But it is mapped up to this host MS1 that we're familiar with. So that's just a basic example of creating a volume on this platform. But let's put our systems administrator hat on and go look at what a VMware environment would look like. So this is my vCenter environment. I've gone ahead and downloaded the VSI plugin from the Dell site, and I've registered it with vCenter. So when I open up that plugin, I get an overview of all of the systems I've got. So I can just jump in here, click on the systems, and see what's actually registered. So I've got 2 PowerStore systems. I've got a T model. I've got an X model, which is the apps on, and I've got 2 Unity systems here as well. So if I just want to expand on this, kind of the pieces I'm looking for here would be here, just to see that my VASTA provider is actually online and connected. Other than that, this is just about retrieving summary information about the appliances. Now, practical use cases for this plugin would be, let's look at adding a new host into a cluster. So I've added a new host into my cluster. Let's just say it's host 4. And when I right-click on it, I get some operations or options for Dell VSI. One of these is applying best practices. I'm a stickler for queue depths. I can choose my PowerStore here, and what this will do is this will give me a full range of settings that Dell has laid out under their best practices for VMware environments, and it will apply them for me. So setting the queue depth for my QLogic adapter to 128, setting my path selection policy to round robin, kind of things that are that I've got to go in and set and make sure that I've got that configured on my environment. This just simplifies it for me. I just check the box of the ones I want, hit save, and it does the rest for me. It saves me logging on, running ESX CLI commands on the on those hosts directly. So outside of that, I want to create a new storage resource, a new data store. So I go to my plugin, I choose the type I want, so I can go VMFS from here, or if I was doing vVols, I can do vVols on both block and file. Now I won't have a file option because this system is deployed as block optimized. So I can choose the VMFS version I want, which is version 6, and we hit next. So now we need to give this a name. So I'm going to call this tvol2. I choose the appliance that I would like to send this to and get it created on. Next, give it the capacity. So we're going to go 55 gigs just for consistency. My policy again, which has been exposed to me here. And if I wanted a protection policy, I can add a protection policy here. Now, I have predefined some protection policies already, and one of those is prefixed with REPL. So this means replication. I've set up replication between my 3000 and my 1000. So just by selecting this here, I'm automatically telling this volume to go and participate in replication. So I don't need to go and establish any new replication schedules. This is already done for me. So, and that's as much as I need to do to have created a data store within vCenter and protecting it across sites. So we can see here our tvol2 is created. Now I can click on it here to go to its configuration menu, and I get a lot more information about that volume because we've got a VSI hook in here as well. So I can see that it's on a 3000P, the code version that's running on it. It's VMFS. I don't have capacity information yet because we haven't put anything on it. But I can see its performance characteristics, the policy it's got, the latency that we're observing against that data store right now. And if we were running active I/O against that, we'd expect to see some additional information here showing us a throughput rate. The protection policy is set to replicate. I can change that from here. I can change the performance policy also from here. So, taking all of this into account, there is actually no reason for me as an admin to actually go and log on to the management interface of that PowerStore array at all, which is just going to make life a little bit easier for the admin. So that would be a typical creation operation. But let's go and look at monitoring, because monitoring and management are a big part of what we do. So I'm going to log into VRops. What I've done in advance is I've downloaded the Enterprise Storage Analytics pack version 6 from the Dell website, and I've uploaded that pack here into my VRops instance. Now, by doing so, it gives me a bunch of additional workflows and dashboards. So you can see here that we've got everything from PowerMax to some of the data protection suite, Avamar, and replication technology. So RP for VM is in there as well, along with some of the legacy platforms that Dell has in its portfolio. So we're interested in the PowerStore piece. So I'm just going to go here and have a quick look at the overall metrics. So we can see here that the 3000 system is registering 195 megs of throughput at the moment. We look at the overview for that system, we can see where the hotspots are. So the one hotspot we're seeing is this MS Test 1, which we can see here is running over 40,000 IOPS. So I can dig a little bit deeper into this. So what I want to know out of this particular investigation is, what node is that volume actually active on and running on? So we get the usual information we're looking for, the policy information, the size, etc. But let's go and have a look at some of the metrics. So let's take a look at the total IOs for this. By expanding performance, we can have a look at our total IOPS. We can see here that we're running, just shy of 50,000 IOPS against that particular volume. But now I want to see which node it's running on. So I'm going to go and expand the PowerStore cluster here. Click on our system, and we get a bunch of different options. So I can look at fiber channel ports, I can look at volumes, but I want to look at the nodes within the appliance. So I'm going to choose node A here and have a look at its statistics. So this is quite handy for troubleshooting as well, and for identifying where we might have a bottleneck or imbalance of workload. Now, based on this, I'm not seeing much information traveling across this guy. When I go and look at node B, what I should expect to see is that it will directly relate or correlate to the information that I'm sending on the volume. So total IOs and bandwidth, and yes, it is. It's showing us our 196 or 198 megs per second and our 48,000 IOPS that are running. So if we want to zoom in on that stuff, we can zoom in, do whatever we want. But this is just, a quick example of how we would use VROps to be able to monitor the performance and behavior of our PowerStore appliance. So the third thing I wanted to show you here was VRealize Orchestrator. So I've got the 8.2 orchestrator, and I want to go ahead and log into my appliance and see what options are available to me. So we log in here, and then we can launch our workflow engine and take a look at the packs. So I've gone ahead already and downloaded the VRO plugins from the Dell website, and I've added them into my appliance already. So we'll get this guy to log in. Of course, it throws me back in there. Pretty sure that when I hit it again, it's going to do what I need. Yep. Okay. Right, so this is just an overview screen just to show us, some of the recent workflows that were run, some of the operations that were completed in here. So we can see that we've got 0 running, 0 waiting, and there were 3 failed. Not too interested in those, but let's have a look at the workflows. So since I've uploaded the plugin for PowerStore, we can see that we've got a Dell EMC PowerStore tab here. If I expand that, we've got some discovery, protection operations, vVol operations here as well. But I'm interested in host operations here. So when we come down through these, we can see that we've got the option to go and delete hosts. We can provision new hosts. So there's a lot of capability around orchestration of hardware. But provisioning now, we'll just expand here on VMware's provisioning, and can see that we've got a lot of different options. I'm just going to widen this so that we can see the full range of operations. So we can create host groups or clusters, RDMs, new VMFS data stores. So what I'm going to do is I'm going to run this workflow, which is to create a VMFS data store for an ESXi host. So when I run this, I now feed in the variables to this. So I can choose a cluster to run this against, or I can run this directly against a host. So I'm just going to choose a host here. We're going to call this VRO TVOL. We'll go for 3 for this guy. VMFS version 6. The size that we want this in, so gigs. Let's just go for 100 gigs of a volume. And I've got a second tab here for my storage information. So the first tab is giving me all of my vCenter information. Now I choose the appliance. I've only got 1 registered. I choose my performance policy, which is high. I want to do replication for this volume, so I'm going to use my replication policy as part of this. And I'm not using a volume group, and I want to just automatically generate the LUN IDs. I'll just run that, and this is now going to go and execute that workflow. So what I'm doing with VRO is I'm orchestrating against the virtual infrastructure, but also against the storage appliance itself. So let's go back and have a look and see what's happened here. So we can see that in the recent tasks, host 7 has had some activity where it's got a data store created. We can see here that we have our VRO TVOL 3, which has been created, and it's on host number 7. So we need to go and refresh that. We'll maybe give it a minute and come back to it. But let's go look at the PowerStore and see what it's done on the PowerStore side. So here's our VRO TVOL 3. Let's look at the protection for him. So there are no snapshots active right now. However, it is on a replication schedule with a 5-minute RPO, which is protecting this volume over to a PowerStore 1000X, which is at the DR location. And the host that this is mapped to is our ESX7 within our vSphere cluster. So very, very simple, easy way to to create resources, again, without actually having to log on to the management interface. So there's a lot of capabilities that can be exposed out to to our systems admins. So that's just a quick run through of how we would use VMware integration into this. So let's look at some of the other options that are available. One of those, I'm going to touch on two more. One of those is PowerShell, and then we've got a Ansible. Okay, so what I've done here is I've installed on this machine the plugin or the module for PowerShell, and I've already gone and created my authentication into my cluster using very secure information, as you can see. So I get some of this get information will return summary information, service tags, code versions, etc. that are running. But the kind of things that are interesting are, if we jump here to line 14, I want to create a new volume. I'm putting it on the cluster I've predefined. It's going to be my marketing volume. I want to size it at 50 gigs, give it a high performance policy, and give it a protection policy that includes replication and map it to its desired host. So everything we've done with VRO, everything we've done through the VSI plugin, okay, which were all pretty quick to do. I have to say, this is kind of the fastest way to do it. So just like that, we have, in a couple of seconds, we're responding to a request from the business. Friday evening, we just want to get out and go home, but we need to go and allocate those resources, and we've just done that. Now, marketing being marketing, from time to time they go, hey, we need more capacity. How do I go and expand that quickly? Again, we've got a commandlet here, an expand -volume commandlet that will give me my new size for the desired volume. So we're going to run that, and it is done in, again, a couple of seconds. Let's go back and look at the system and see what it's done. So we've increased our number of volumes. We've now got a marketing volume sized at 80 gigs in here. It's replicating. Okay, we've got no snapshots against it, but it is mapped up to host 1. So let's just go back and take care of that. Okay, again, somebody who doesn't have access to the back end needs to take a snapshot. So we're going to create a new snapshot here for marketing volume, and we call it update snap. So we'll just run that. Okay, done. We've now snapped it. Because we've snapped it, let's just go and refresh, and we can see here we've got our update snap. So PowerShell has just got immediate response, generated the snap as quickly as we wanted to, and it's on a 5-minute RPO. So somewhere in the next couple of minutes, this is going to go and take that snapshot and replicate it to the destination, which is my PowerStore X on my edge location. Okay, so very quick, responsive tool, which again is ultimately leveraging the REST API capability of the platform. Likewise, there's a PowerStore CLI utility, which is quite similar, although for me, I think the PowerShell module is really, really cool. However, there are people who don't use Windows. If you use Linux for your environment, you can use this PST CLI. Again, quite similar in what it does. It's achieving the same thing, but in a slightly different way. So I can use this utility, download it, and install it on a Linux appliance, a Linux host, or put it onto a Windows host. I've got a couple of variants of it. It does the exact same thing as what the REST API will do, as what the PowerStore or PowerShell module will do as well. Just does it in a slightly different way. So we can see here the contrast is that I'm laying out my information here in a slightly different format, but it's the same information that is being presented back up to me. Okay, so some of the quick tools for quick operations we need to do on a daily basis. Now let's go and take a look finally at how I would use Ansible within this environment. Okay, so everything I'm going to create here is going to be prefixed with Ansible. So we can see here that I've got a number of different playbooks. And just before we do that, okay, what do I need to know about Ansible? So I go to GitHub and I search for Ansible, PowerStore and Ansible. And within the repositories, I get a bunch of playbooks that I can download. Prereqs are I need to be running Ansible 2.8 or higher, and my Python version needs to be 2.7 or higher. For me, I'm running version 3 of that on a Red Hat server. I want to run it on CentOS. There are a number of different operating systems that are supported, and the modules themselves range from block specific to things we can do for NFS, for any of our NAS modules as well that are built in there. For my environment, I've pulled down the playbooks and I've modified them to talk to the PowerStore 3000 system I've got within my lab. So simply to run them, in production, we would run them as a single playbook. However, I've broken these out for demonstration purposes. So the first one is going to create a host for me. So we initiate the playbook. So it's going to create a host called CSC VM03, and it is going to create some volumes and map them out. So just like that, I've created the server based on the HBAs or WWNs that I've presented for my fiber channel host, and it's already created those entities and records within PowerStore. So the second one I'm going to run then is going to be for creating a volume group for those volumes that have just been created and just modify the mappings. So you can see here, quite simple to do. I'm also going to create a snapshot rule because I want a specific snapshot rule for this set of resources that I'm working with. And everything that we're creating here is going to be prefixed with Ansible, so they're easily identifiable within the environment. Okay, we're going to run the second last playbook, which is a protection policy. So we're going to take that snapshot rule, create a protection policy, and apply that protection policy. Okay, now we've got the majority of the work done. Bearing in mind that I only need to issue this command once to create everything that we're doing here manually. Okay, we're going to take the policy that's just been created and apply that policy against the volume group. So this is quite easy to stand up, but let's go back and take a look at it now within the environment. Okay, so our volume count has gone up. We've gone to 14 volumes now. You can see here I've got 4 different Ansible volumes. When I move towards the right, I can see here that they've got a single host mapping and they've got a protection policy of Ansible policy 1. So let's have a look here under volume groups and see what we've got. And I can see that we've got an Ansible volume group using our Ansible policy 1. Let's have a look at the members of that. So the members of that are the volumes that we've created, Ansible 1, 2, 3, and 4. And now we'll go and look at the protection policies. So we've got a brand new protection policy that's been created here within the environment, which is our Ansible policy, and it's got its own attributes. So it's got snapping on every 30 minutes on a Monday, Wednesday, and Friday, with a 24-hour retention, but no replication as part of that policy. Some of the use cases for this kind of things are responding to test and dev requests. Late in the week, somebody from engineering or software team has said, "Hey, I need these resources. I need to get this code developed for ahead of Monday's launch. Can you please help me?" If we have to do this in the old way, if you want to call it that, there are a lot of pieces we need to do to be able to do that. However, something like Ansible allows us to react and respond to the business in a much quicker fashion. Okay, and that's kind of what we're doing with this. Now we're going to get to the other side of that as well, is that this is up and running for a number of days, and you can be sure that the test and dev guy is not coming back to say, can you, I'm finished with this, do you want to tear it down? You're going to have to go chasing them, okay? And eventually you're just going to be so busy that you're going, oh, I'll leave that, I'll do it another time. We get data center sprawl as a result of that, and that's a whole new set of headaches. So very simply, another nice little feature of Ansible is a cleanup, so a deprovision and cleanup. So what this is doing is, nice and simply, before I head out to lunch, I'm going to run that playbook. Oh, that's what I do there. Problem between the keyboard and chair. If I ran the command properly. So it's our Ansible playbook deprovision. What that's done here is, if we look at it, disassociate the protection policy, delete the protection policy, the snapshot rule afterwards, delete the volume group, then go and unmap all of the volumes from the host, delete the host, delete the volumes, and we have a full cleanup. So let's go back and have a look. So we're back to 10 volumes. We don't have anything here that is prefixed with Ansible. We don't have any volume groups within our environment. And when we go back to our protection and look at our protection policies, we don't have any protection policies within our environment here. Okay, so that is just to summarize what we've looked at today. We've introduced the PowerStore technology, the three pillars that this platform is built on, and then we've gone to taken a VMware view of this to see what integration exists today. So we know that there's VRealize capability for this platform. There is VROps integration. There is VASA integration. There is VRO integration as well into this platform. We've taken that a little bit further and looked at CLI. We've used REST API, the PowerStore CLI, the PowerShell module for this, and then gone and layered Ansible, a very common industry standard automation package, down on top of this to be able to automate those day-to-day operations against the PowerStore system. So I hope you found this session useful and take away some information from it, and have a great event.